Hey, this is Kenneth, and today let's talk about simplex repeaters. I started this lecture series talking about conventional repeaters, which tend to have relatively expensive antenna combiner systems, since they typically only have about a 5 megahertz offset, and you're talking several $100s to several $1,000s for a duplex cavity filter to combine them. I then talked about crossband repeaters, which are a little bit cheaper and easier to get into, since they have a several hundred megahertz divide between their transmit and receive frequencies, so you can use just a cheap $30 diplexer to combine the two radios into one. A simplex repeater goes even easier because it only has one radio. So the block diagram consists of just a simplex repeater controller, one transceiver, which acts as both your transmit radio and your receive radio, and an antenna. So no antenna combiner system at all. The downside to simplex repeater systems is they aren't full duplex or continuously repeating live. What they do instead is you key up your radio remotely, it hears your transmission and records it, and then it sends it back out once you unkey. So this probably sounds pretty weird if you were to try and use one, because you would say something, you would then unkey, and you would hear yourself say that again, and then the remote user would have to know to wait until he's heard it both times, or the second time if he can't hear you, and then he would have to respond. I was a little hesitant to record this video because I've never actually used a simplex repeater. It's a little bit ridiculous, and it's something that has been most popular with the comm prepper types, and so it's kind of a squirrely system that you wouldn't see in a serious commercial deployment, but it looked like kind of an interesting little system to set up, and so I emailed one of my good friend Scott Miller, because I've worked with him before on my master's thesis, and I actually asked him to send me a Argent Data ADS SR1. This is his simplex repeater controller, which is one of the most popular ones, and it's a very neat little box. And so let's talk about a specific design example of building a simplex repeater using the Argent Data SR1. So much like the RIC that we used in the crossband repeater controller, you've got your repeater controller that will have an audio interface cable that will build to a max track. The max track will actually feed power into the controller over it's got a 2 amp 12 volt accessory power pin on the back, and then it just goes out to the antenna, which in our case will just be the dummy load inside of my service monitor, right? And so this is going to be a reoccurring theme on pretty much every repeater controller interface. You've got 5 important signals plus ground. So you've got your ground signal plus power, all right, because something needs to power the repeater controller, and then you've got in each direction a audio signal and a binary active signal, right? And so from the repeater controller to the radio, the transmit audio, you'd have the transmit audio plus the push to talk, right? So the push to talk signal would go low when the repeater controller wants the radio to key up. In the opposite direction, you would have the receive audio going from the radio to the controller, and the COR, or carrier operated relay signal, which the radio would bring low whenever it is receiving something on the antenna, right? And so between the repeater controller and the radio, we need 6 lines, right? This is where we go to my wonderful radio notebook, which in it I happen to have a page on the SR1. So in the top section I have just a quick cheat sheet to myself. So we've got the SR1 actually uses an RJ45 connector here as its radio interface, and I've got the pins 1 through 8. So you can see pin 1 is the COR input, pin 2 is ground, pin 3 is audio out, pin 4 is ground, pin 5 is push to talk out, Pin 6 is audio in, 6 is not connected, so you don't use that for anything, and 8 is the power in, right? Inside the SR1, there's 4 dip switches. The first 2 are the transmit audio boost, and the more transmit audio boost is depending on how much drive you need to put into your radio, mainly kind of essentially depending on whether it used a dynamic microphone or an electric microphone, or what kind of whatever kind of signal, you may need to adjust those 2 switches, which I'll show you with the service monitor. The third dip switch is kind of a power on reset switch. So if you want to reset the SR1, you would turn the switch on, power it up, power it off, turn the switch off, and then it would be reset. And then 4 is a push-to-talk on mic line combiner. This is relatively unusual in repeater controllers because the ADS SR1 is actually designed to be used with handheld transceivers. This makes a lot of sense for some applications for it, because if you think about it, here is the ADS SR1. You can actually run it off of AA batteries, and Scott provides, through his store, interface cables to pretty much every standard HT interface. So notice that this goes from the RJ45 to the standard Kenwood 2-pin, so that then you could you take any Kenwood accessory compatible handheld, plug it in, and you would have a Simplex repeater. I'm not a big fan of this because I've seen a couple guys melt HTs trying to set them up as like IRLP gateways. Handhelds are not designed to be keyed for a very long time, and when I've got as many max tracks laying around as I do, why not just use one of those, right? But the idea is that you can take all these 3 things, which are all relatively cheap, throw them in your duffel bag, and just have them available. So if you need to toss up a Simplex repeater somewhere, it's relatively easy and cheap to do. And this would be battery powered. This would be battery powered. But that's not what we're going to do. We're going to actually design it with a Motorola radio, right? So here's my my scratch VHF Maxtrack 300. I've got it programmed for my 146.535 Simplex channel that I use all the time. And then all we got to do is design this interface cable, like this one, that has transmit, receive, push-to-talk COR, and power on it. The bottom half of this notebook page happens to have just that. So you'll notice on the left side here I've got the SR1 8P8C or RJ45 connector. That's right, with its pin out. I then have in the center the 568B color code, since 8P8C is the same connector used for Ethernet. And so literally what I did was I took an Ethernet cable, cut off one end, and used the existing RJ45 connector on it, and then I just had to put the Motorola connector on the other side. So, the audio out from the SR1 goes to the flat audio in pin on the Motorola, which is pin 5. Push-to-talk out goes to push-to-talk in. Discriminator out from the radio goes to audio in on the SR1. The COR out, which in this case, since this is a VHF radio, my personal convention is I use pin 14. So pin 14 is then connected to the COR in pin. And then the accessory power pin on the Motorola is wired up to power in. Right. I'm not going to sit here and kind of tediously build this cable for you, but this is what it looks like. Right. So we've got an RJ45 connector on this side. Green is the standard color code boot I use for audio connectors, just so I don't get them mixed up with other Ethernet cables laying around in my radio sites. I've got a little RF choke here, and then on this side, what I did is I took a empty Motorola accessory shell and then crimped onto 6 of the pins, the connectors, which you just shove them into the connector shell and they click in, and then they don't come out again without a little extractor tool. And then I zip tied it to the strain relief here. Right, so we can plug this into the Motorola. This plugs into the SR1, and that's it. It's pretty clean. Alright, so let me get rearranged here, and we'll fire up the service monitor, and then I'll show you kind of the basic configurations and what it kind of sounds like as I talk into an HT and key up this SR1. Alright, so I've got my service monitor fired up, got the Motorola radio powered up and plugged in. SR1 interface is brought in. On power on, it just shows both lights for a second there. I've done a power on reset on it, so I flipped the third dip switch, powered it on, powered it off, turned the third dip switch off, just to show you what the dip switches look like. This is the battery compartment for the two AA's. Then there's a piano style dip switch right there. So I'm not going to show it to you, but while we're looking at the service monitor, we're going to need to flip a couple of these switches. So every time that you wire up a new repeater controller to a new radio, you want to do a repeater gain alignment, right? So you want to make sure that the audio coming out of it is just as loud as the audio going into it. Before we do that though, I'm going to run one command to tell the SR1 to use the COR signal, right? As it's designed to be used with handhelds which don't have a COR signal, and so it by default uses Vox, where it just listens for sound. Since our radio supports COR, we may as well enable that function. In the Argent Data SR1 manual, it shows that to set the COR mode to active low, which is what we want, the command is #1092. So here we've got a handheld on the same channel as this, and I will key it up and then send #1092, and the SR1 should respond with 3 high beeps to confirm the transmission. Alright, so there we go. So now we've got it in COR active low mode, which is just kind of nice. And now we can actually start the alignment. So coming up here and looking at the service monitor. Oh, sorry about that. So same as before, we want to go to antenna analyze. Dial in the frequency 146.535 megahertz. We want to select the correct input port as RF in, and then we want to go to RF generate. So now what we're going to do is we're going to generate our standard check 3 kilohertz deviation, 1 kilohertz tone, play it for several seconds, and then we're going to unkey the service monitor and have the SR1 repeat it back to us. And we then we would hope that the FM deviation would be the same coming back out of the SR1. To adjust the transmit level out of the SR1, there's the 2 dip switches to boost the transmit gain, and then there is a DTMF command #11 that then lets you set your transmit level in essentially percent. Right, and so by default it's at the highest level, 99%, and then so what we'll want to do is we'll want to set the dip switches, keep turning on dip switches until our deviation goes above 3 kilohertz, and then use the DTMF command to dial it back down to just 3 kilohertz. Right, so let's zoom in here on the screen. So we're going to RF generate at 146.535 as well. We want to go out into the RF out. We want to generate 1 kilohertz at 3 kilohertz deviation. We want to generate 127.3 hertz at 600 hertz deviation. So again, this is our PL tone that we're emulating here, and this is the actual check tone that we want to feed into the SR1. So now if we turn on the generator and set it to a reasonable level, like minus 80 dBm, you can hear there's our 100 hertz tone. When we turn it off, the SR1 should come back. You'll notice the deviation's only at 1.4. So I'm going to turn on, I'm going to open up the battery compartment and turn on the transmit boost switch, which is dip switch number 1. Turning on the service monitor again. We'll play it for a few seconds. And wait for the SR1. You'll notice at 2.6 still hasn't actually made it up to R3, so we need even more TX boost, which is dip switch 2. So I'm going to turn dip switch 1 off and dip switch 2 on. Key up the service monitor, and then unkey it, and the SR1 will come back. Now you can see we're over-modulating, right? So we've now gotten above 3 kilohertz. So now what we can do is we can start running the #11 command to set the TX level to try and dial in just at 3 kilohertz, right? So it starts at 99. We can't go any higher, and so let's pick 80. So what I sent there was #1180 to set the transmit level at 80%. Notice it's still too hot. You'll notice that the actual deviation didn't change much because the radio went into what's called limiting, where we were trying to send it a signal that would cause it to have deviated beyond the 5 kilohertz limit, although in this case it appears to be a little bit less than that. And so even though we turned the transmit level down by 20%, you didn't see a difference. So we need to keep going. So let's go down to, say, 60%. Alright, so it's confirmed that it's at 60%. Unkey the service monitor. Still a little hot. Alright, so let's go down to 50%. Alright, so that's right about spot on. So at this point I'm pretty happy with that. So let's walk through the rest of the configurations for just kind of a basic ID on it, because the FCC requires that our automatic station here IDs, and with the RIC we weren't able to do that, which is why it wasn't a legal repeater, but with this we can actually set up a reasonably legal automatic controller. So let's zoom back down here. I shall try and turn off the service monitor without bumping the camera. So at this point we've got the transmit levels set pretty well, so I can sit here and actually talk into it. This is Whiskey 6 Kilo Whiskey Fox speaking into the Simplex repeater.
This is Whiskey 6 Kilo Whiskey Fox speaking into the Simplex repeater.
Alright. So that's the actual value here. Is we have a repeater. We have this radio which will, mimic back to you everything that you say, right after you say it, right? Which makes the conversations which probably makes the conversations relatively stilted, but is a whole lot better than nothing if you wouldn't be able to hear the other person otherwise. But now we need to set up some sort of automatic ID, right? Is we need this radio right here to at least every 10 minutes for Part 97 amateurs license, every 10 minutes transmit its call sign, right? And so we're going to operate this under my call sign W6KWF. And what I typically do for repeaters is I will append like a /R, or in this case I'm going to put a /SR to indicate that this is a simplex repeater. right? So W6KWF/SR. So every 10 minutes, it'll beacon that string in Morse code. The way to set this is in the Argent Data manual, in the command reference, it has this #82 set CWID text and a big table with all the different characters that you can send in text, right? And so I have, ahead of time converted this string W6KWF/SR into the DTMF command I need to send it. So now if I'm lucky, I'll be able to actually key all this in successfully. Alright, so it played it back in Morse code and then did the triple beat to confirm it. If you aren't quite as good as at Morse code, which I am not, I need to hear it again, #86 will play it again for you. Alright, so yeah, I got that right. It says W6KWF/SR. Right, and then to turn on the CWID, it's #801. All right, so now every 10 minutes it will just beacon my call sign from now ad nauseum. This is not wrong, but is a little bit annoying because if no one's using a repeater and it's not transmitting, there's no requirement for this repeater to actually transmit every single 10 minutes with its ID. And so Scott has implemented a feature called the CW Cleanup ID, where it only does this if there has been activity in the last 10 minutes. To turn this on is #803. Alright, so now we've gotten this repeater to a legal state. So it will sit here silently from now until forever, with the exception that if I ever key it up, Whiskey 6 Kilo Whiskey Fox, keying up the Simplex repeater.
Whiskey 6 Kilo Whiskey Fox, keying up the Simplex repeater.
At the end of this 10-minute interval, it will then automatically Morse code ID and then go back into idle mode. Which meets FCC requirements. We have built a legal FCC automatic remote control station here. It's not technically a repeater because it's not full duplex, but we're legal. We're finally legal. So congrats. That being said, I have barely scratched the surface on the SR1 capabilities. This is a very, very smart little box that Scott's put together. It's got a voicemail system. It's got voice beaconing. So if you want to put, update, kind of news and update stuff that gets beaconed periodically on this channel, you can do that. It has a on-off switch so that you can actually have it standing by, and you can then key it, tell it to act as a simplex repeater only when it's needed, so that if everyone happens to be in range of each other, you don't have to deal with this kind of long protracted repeat of everything. But I mean that's totally dependent on what you want to do with it. That being said, I'm looking forward to trying to deploy this on a couple of the field trips that my friends and I do, and we'll see how awkward or how useful it is, and I'll certainly make sure to report in when it is. So again, thanks to Scott for giving me a free SR1. That was much appreciated. And any questions or comments, leave them in the comments. Other than that, thanks for watching.